Okay, so we've got our wireframe modified. Now we can go to our swarf toolpath. We can go to the cut pattern and we're going to choose chain. I'll select the chains. And now it says define the lower contour. Before I start selecting my chains, in the options in the chaining dialog box are some controls that allow us to synchronize sections of chains. So I'll click on that button. And down at the bottom of the dialog box is an option called sync mode. Synchronizing branches in your chain tells Mastercam that you want to maintain a relationship between the upper and lower rail as far as driving around. And one of the things that can happen if you don't synchronize, Mastercam is going to do an even step increment on the top and bottom chain. And based on the chain length, sometimes your tool can get tilted either forward or behind the cut direction because you haven't synchronized your chains. We're going to synchronize by entity. That means that there's a one-to-one relationship between the number of entities on the bottom chain and on the top chain. Otherwise, we could go and create points where we wanted the chains to be synchronized, or we could try to synchronize by branches. So I'm going to sync by entity, and now I'm going to choose the lower rail. That's my lower rail there. Now it says define the upper contour. I'm going to grab my upper rail there. Same settings that we used before, but we're giving it different geometry. Now we don't have any lead in and lead out enabled, so let's go to linking, and under linking we can do our entry exit. Okay, so we're going to do a 1/4 inch length and thickness. And now, because we've got some lead in and lead out, we're no longer hitting that operation surface. So here we do our entry motion, and now you can see that the tool, if I look from the top view, that the tool is basically maintaining tangency between these two rails as it kind of sweeps along these surfaces. Now the thing that we've got to be careful, you can see that by being tangent to the bottom rail and the upper rail, that my tool is actually gouging this surface a little bit. This surface must be perfectly straight between these two rails in order for us to truly cut exactly what's there. Otherwise, what we're going to need to do is try and use some of the tolerance of the part to account for the fact that these surfaces are not, either concave or convex. So that's really one of the limitations of swarf, is that you want to make sure the shape you're cutting can be cut by just taking the tool and using the flank or the side edge of the tool and driving around. Okay? If we were really concerned about gouging into this surface, one of the options we've got Oh, sorry. This swarf toolpath is Mastercam's original swarf toolpath. And there are some options that are in this toolpath. Um, I should say it this way. This toolpath has some very kind of simple options for driving the tool and controlling it. And it's easier to learn this toolpath than the other toolpaths because there's less options that you have to check. Mastercam also has a second swarf toolpath. So if I choose toolpaths, multi-axis, and we go look at the surface solid menu, you'll notice that we have another swarf milling toolpath here. This swarf milling toolpath is the module work swarf milling toolpath. So it has some different features and options that aren't available with the classic toolpaths. Select the same 1/2 inch flat end mill. Under the cut pattern, I'm going to grab the surfaces that I want to compensate to. Oh, I don't want that one. That was on the back side. So those are my surfaces. I am going to give it the upper and lower curves. So my upper curve is this curve here, and my lower curve is this curve here. I want to be sure we're machining on the left-hand side of those curves, and we're going to be climb milling. Start point, we're going to do exact, and when I turn this on exact here, yeah, that's good. Tool axis control. Under the gouge check, this is the reason why I kind of like this swarf a little better. We can have it check against the wall surfaces, and we can say you've got basically degouging, you've got avoid by relinking, and you've got avoid by retracting. So I'm going to tell it that the gouge allowance is 3 thousandths. And we'll leave kind of the rest of the defaults. And if I backplot that, we're getting really nice smooth motion. And this swarf toolpath actually adjusts itself outwards to degouge the toolpath. So here we're telling it what the maximum amount of gouge allowable is. We're saying 3 thousandths of an inch. So that will produce, now there's still going to be, if this is a convex surface, there's still going to be a little bit of excess material that may be there that may not exactly match the model geometry, right? But it's going to be hopefully close enough, hopefully within your tolerances, because this, taking a tool and running around a feature like this to finish it, is going to be much more efficient than if we were just going to take a ball end mill and try to surface machine that piece right there. Okay, and yes, with kind of both of these, we can do multi-passes. So multi-cuts. We're going to do we're going to do slice distance. Take 2 cuts at 50 thousandths. Oh, sorry. This is this is actually depth cuts, and pattern layers is multi-passes. sure I close that machine sim window. Okay, so it's making 3 passes now instead of 1. And there we go. Makes our first multi-pass, second multi-pass, and third multi-pass. Okay. So we're getting close on the time here. That's okay. We got about 30 minutes left. I'm going to try and cover the 5-axis flowline toolpath. I'm going to talk about using that. And also just want to remind you guys, this training is for your guys' benefit. So if there's questions you've got about multi-axis machining, please go ahead and bring them up, in this last 30-minute window that we've got. Because we're going to go ahead and try and end this class right on time today at noon on the West Coast, 3 p.m. on the East Coast. So, okay, we're going to go and do flow 5-axis. If we look at the shape of this surface, maybe this surface is critical, and we want to make sure that we finish it with a ball end mill, and it needs to be fairly accurate. Toolpaths, multi-axis, and I'm going to do 5-axis flow. We'll grab a 3/8 ball end mill. Okay. And cut pattern, we're going to select the surfaces. When I select a surface, the surface that I'm selecting is my tool pattern. And by tool pattern, we're talking about the method that we're using to step over and step across on that surface itself. I'm going to select those surfaces as my pattern surfaces and press End Selection. When I do that, we are now picking our flow line directions. So with flow line, you can control the way that the tool steps across your set of surfaces. Offset chooses which side of the surfaces you're going to be cutting on. The default is to cut on the normal side. So you always want to make sure you check your normals first, and if your normals are correct, you should never have to worry about that offset button. Then we have cut direction. Whenever we define a surface, that surface mathematically is defined by 2 numeric parameters. A U curve direction and a V curve direction. Those are just the parameter letters, if you will. They're called U and V. So when I click on cut direction, I can either cut along or across, basically either on the U or the V direction. If I click cut direction, you can see now that this pattern flows and follows the shape of the surfaces, except for here. Look at this surface. So if I click cut direction again, this surface was built as a square, and then the shape was trimmed. So the cut directions are not going to work if we try to flow along this way. I mean, they could maybe, depending on our stepovers and our settings, but a lot of times this will cause what's called a surface flow line conflict. for that reason, what I'm going to do is go back in my surfaces, and I'm going to deselect that top surface. That's flat anyway, so it would be silly for us to not cut that with a flat end mill. It would be silly for us to stitch it unless we needed to make sure that the blend into these two surfaces was perfect. Okay, that'd be the only way that I would not cut that with a flat end mill. So now when I look at my flow directions, you can see that these directions flow nicely across that set of surfaces. So once I've got my cut direction set, I can click on step direction, and that basically chooses, do I want to start at the bottom and work up, or do I want to start at the top and work down? Then I can also choose my start point. Do I start on the left-hand side and cut that way, or do I cut the other way? Most of the time, when we're using flowline, we're finishing. And so we typically want to do a zigzag pattern. If there's only a tiny bit of material left on the surface and we're cutting with a ball end mill, it doesn't matter whether we're cutting climb or conventional. The one exception to that, I guess, is if you're doing, like a heat-resistant super alloy, or if you're doing titanium, and you really need to maintain a specific cutting direction. But what we're going to choose is zigzag. We've already done the flow parameters. We have our step along, which is going to be based on a tolerance, and then our step across, which can either be based on a distance or on a calculated scallop height. Now we come to tool axis control. So the default is lines, but we can use, any one of these options here. So what I'm going to do is use from point, and then I'll click on the select button. Now it tells me to select a point. I'm going to go to the top view. We're going to fit to the screen, and I'm going to put a point maybe right here. And so what I'm going to do is just hit the space bar, and I'm going to do -5, comma 0, comma 10. I'm going to put it up at 10 inches in Z. So I just created a point where I want to direct my tool from that point. Collision control is just going to be on a set of surfaces. So I'll take that. Oh, I'm not doing that one. I'm just doing these guys here. So same set of surfaces. And you can tell it for the compensation surfaces whether you want to ignore surface normals or whether you want to allow undercutting. We'll leave the rest of the defaults. And if I backplot that, you can see that we are, you know what I've got? Under my flow 5-axis parameters, under tool axis control, look at this. I've got my output set to 4-axis. I want it 5. Now, from point is probably not the best tool axis control method that I could be using here. So let's do this. Going to set my Z depth to -5. We'll make sure we're in 2D mode, and I'll create a point by position so that we got a point down below. Now I'll change my option to 2 point. Choose that point instead and regenerate. That looks a lot better. Okay, so just by changing your tool axis control method, you can completely change how the cut pattern is going to be applied with the tool axis control. Okay, so you can see that we're kind of maintaining clearance on everything with our holder. We're going to get up to the top, and we're basically just going to step over because we told it we wanted to create a scallop that's 1,000th high. So we're just going to zigzag back and forth across that set of surfaces, and we get all of our 5-axis tool axis control methods available to us. Okay, I mean, the other thing I can certainly do, cut pattern one way, and we also have the option for spiral. So if you've got a surface where you kind of want to spiral on the surface, you can do that as well. If I go one way, looks like I'm conventional milling. So I'll go to my geometry, I'll go to my flow parameters, and that's going to be conventional. So if I click on step direction, that's going to be climb. I'll regenerate. And if we backplot that, there I'm making my first pass. Second pass. Third pass. Okay.